All right, so we finally got everything up and running, or at least something. So my name is Felix, and this is Guillaume. And we are both working on the Dotty project together with Martin Odersky. So today we're going to show you how to go from nothing to a PR in Dotty. And so everybody should start by cloning the Dotty repo if you haven't done so already. I suspect that since the connection is quite poor, that might take some time. So if everybody could start doing that, that would be great. And also, you guys should definitely move forward if you want to get some help during the session. So yeah, now we'll just see if Guillaume can get his screen up there. All right, cool. So the first thing Guillaume is going to do is to clone the Dotty project. All right. So since that's probably going to be pretty slow, we'll let that run in the background. And in the meantime, we'll show you how to create an example project that uses Dotty as the compiler instead of ScalaC. All right. So the first thing you need to do is to specify the Scala version in SPT. And we've done it so that any version beginning with 0 is automatically going to be detected as a Dotty version. So now Guillaume wants to look up what the latest Dotty version is. Each night we publish a nightly snapshot of Dotty. So we publish it with the date and the latest Git hash that was merged. So the easiest thing to do to get one is just to go to Maven search and copy paste into your build file. All right. So once that is done, you need to set the Scala organization to ch EPFL lamp, which is the organization we're publishing under. And you also need to set the binary version to 211. And this is because we share the compiler, the Dotty compiler shares a backend with 211. So that's the version that we are currently backwards compatible with. So once this is done, you also need to create a project file and a build properties file, because you need to use an SPT version later than 0.13 point what?
Yeah. Currently, you should use 11 because it's the least broken one. But using 0.13.14 will be even better because you won't need to do what I'm going to do now, which is set the Scala compiler bridge sources, which is how we get SBT to compile code using Dotty and not using ScalaC. So I don't remember the exact line, but you can go to github/smarter/Dotty example project, which you can also clone. And there is an example build.sbt, which has the correct line, which is this. So I'm going to copy paste this. It's a bit long. All right.
All right. So now that we're done with the build file, we can actually boot up SPT and use SPT like normal. So Guillaume can now create a main class, hopefully. Right. All right, great. So now we have an SPT console. And you can compile, and it will resolve all the binaries as per usual. So once this is done, we can use the tasks that we currently have implemented with SBT. And the task that we're supporting currently is console as well as compile. So we currently don't have an interface for the new documentation tool, but that is to come later. All right, cool. So now Guillaume can show you the new console. So the first thing you'll notice is that we have syntax highlighting, which is due to the fact that we're basing our terminal interpreter on Ammonite. Yay, hello world. All right, cool. So now Guillaume is showing you that you get a union type out of conditionals. And as you can see, union types provide you with complete knowledge of the types that you're matching on. So you can sort of think of union types as some form of supercharged any where you keep type information. All right, so that's pretty neat. So how is it going with our cloning of the Dotty repo? It's done. Awesome. So now that we have Dotty down, we can start to look at the build. So as you can see, there are a couple of directories, and all of these contain their own self-contained project. So there is the compiler, of course, which contains the sources for the Dotty compiler. There's also a library, which contains the runtime and reference to the old Scala library. We also have a doc tool, and we have some interfaces and other things there. But the thing that you will be looking at the most if you're planning on contributing is probably the compiler. So let's have a look in the compiler. So let's look at the, I guess, the main compiler class. All right. So this is where all of the faces are defined. So in Dotty, you will find a long list of faces. So as you can see, faces is a list of faces, and Dotty has something that we call face fusion. So here you'll see each list that is here consists of a macro face, and each face listed inside of here is a mini face. So I will talk more in detail about this in the talk this afternoon. But if you're looking to change something in how in the compiler pipeline, this is where you should start looking for the definitions. All right. So what should we do? Should we implement some error messages or?
Sure, but I don't know how.
All right. So can you give me VI?
Yes.
All right.
Do you want an English keyboard?
Yes. Thanks. Sanity restored.
Okay, so contributing to a compiler might seem like a very complicated task, but in reality, in a compiler, there are a lot of things, and not all of them involve highly complicated type systems and constraints and type theory and that kind of things. There's also a lot that has to do with user experience and user interface. And one of the main things is error messages. Nobody likes it when they get an error message they don't understand. So we would like it if in Dotty, all of our error messages had nice explanation for everything. So, and this is something where everyone can contribute. If you have a good idea of how to explain an error message, then as Felix is going to show you, you can make a detailed explanation for an error message. When you run the compiler, it will not show the detailed explanation by default, but if you use the -explain flag, the compiler will show you the long explanation. So this is useful for error messages that you might not understand. And so far, we have received many contributions from external people who had never tried to use Dotty before, and who successfully made pull requests against Dotty by contributing new error messages. So this is a great way to contribute. So this is an example of an error message. So here there is nothing special. You used a list of int instead of a list of string. Although you can notice that Dotty will highlight in a different color the int and the string, which is the different part of the type. So if you have long, complicated types, and only a small part of the type is different between the found and the required, you will get different color for the part that is different.
So the idea here is to, like, before error reporting used to be something that's purely string-based. You get a string that the compiler developer thought was adequate for your understanding and whatever's wrong. But what we want to do in Dotty is to put semantic meaning into the messages. So there's actually something for tools to work with. There should be something like a explanation if you're a beginner that should, summarize what's wrong with the current with your message. So I will talk more about this during the afternoon session, but it's quite simple to get to the point where you have an explanation, and I'll show you that this afternoon. So implementing an error message is quite simple. You only extend this class and give it an enum that's a stable identifier for the class. So the only thing you have to give it is a message, a kind, which is something like a syntax error or a type error. And then the explanation is something that should be a bit more verbose, but is not something that should be given to the user by default. It should be something that's presented when the user asks for it. All right, where's the sure. Is it in? All right. Cool. So concretely, the message is going to be this thing, right? So this is going to be the message, and this is going to be the type up here. So as you can see, messages are now, they're colorized. The line number is highlighted where the error occurred, and they are also separated by something that, instead of getting this huge wall of errors, you can actually get something where you can discern where one error begins and one ends. So now to look for something to find out where you can implement an error, you should simply do a grep, right? So you do something like context.error, and we are going to look for a string like this. So if we grep for this, we're going to find occurrences in the compiler where errors are issued that don't have a semantic message yet. So all of these errors that you see here on the screen are errors that we haven't converted to this new format yet. There's also another way to find out what errors are missing, and that's to go to the can you go to the issue?
Yeah. So our project is on github.com/mpfl/Dotty, and on our issue tracker, we have some issues which are marked need help or something like that for people who, and we have especially one issue about all the error messages. If I manage to find it. Oh, but the keyboard is in. Yeah, so there is one issue which is called missing error messages. You can also find it from the blog post on this subject. So the blog post is on the official Scala website, scalalang.org. And there is one blog post called Awesome Error Messages for Dotty, which repeats a bit what we said before and contains other information you might find useful. And at the end, it points you to the error message issue. So this contains a small explanation on how to make new error messages and a list of error messages So if you want to contribute and make an error message, you can go on this issue and say, I would like to work on this, so that not two people work on the same thing at the same time.
All right, go back to the terminal and give me a US layout. Thanks. All right, so instead of actually implementing an error message on the stage now, we're going to have a look at one of the most common error messages that you get, which is the type mismatch. So all the messages are contained within a file, which I should be able to find, which is in the diagnostic package. And it's called messages.scala, simply enough. And here you'll find all of the messages that we have implemented that have these, that have some form of semantic meaning. So let's find the type mismatch error message. All right. So as you can see, it's just a simple case class, and it takes two parameters, the found type, the expected one. And you can also get a more detailed explanation sometimes from the compiler, which is the why no match string. So here, you'll see that we just set the kind to be type mismatch. And that's, you could set this arbitrarily. I mean, in the end, we might have some form of sealed ADT to actually serialize this to give you, specific categories that we curate. But for now, use your best judgment, and we'll review it. So as you can see, the message is quite simple. The only thing we do is that we use some helper methods, one that disambiguates the types, and the other one that performs this type diff that you guys saw earlier. So if you're doing like a lot of type level style programming and you have very advanced types, Dotty will actually help you now in disambiguating where your type errors come from. Simple thing, you just return a string interpolator where we say the found type and the expected type. So here we also have a couple of other helpers for you. So for instance, we have there is something on try, I think. Try. Catch. All right. So there's this error message that's called empty catch or finally block. So in Scala, you're allowed to have a try without a catch or a finally. That's perfectly valid, but it doesn't do anything. So it's, you could have left it out. So in this message, we explain to you how a try catch works. And it's quite simple. So we use a string interpolator that's called HL that gives you syntax highlighting. So you can actually have syntax highlighting in your error message to help your user. So here it simply explains a try expression should be followed by some mechanism to handle any exceptions thrown, blah, 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 blah. And then here, this is the important part. So code 1 and code 2, they're actually using the user's own code to show them how they should have written their code. So in the end, the user can simply copy paste the code that is given by the explanation into their program and continue on with their day. And that's sort of like to the point we want to get. We want to get to the point where the compiler is helping you, not just being this nagging, annoying thing that just complains about all your type errors. All right. So what should we do now? ID, yeah. Maybe. All right, so cool. So I don't want this to be like a static thing where I just talk and Guillaume just talks. If you guys have questions, just like raise your hand and we'll try to answer it. It doesn't have to be on contributing. It can be on Dotty or where Guillaume gets his haircut or whatever. All right. So if there are no questions, Guillaume is going to demo the IDE. All right, so let's do the IDE demo.
Okay, so in my talk yesterday, I talked about IDE support in Dotty. And now that I have a computer that's working, I might actually be able to show you this IDE support. Oh no, I'm in Vim. How do I exit? Ah! All right. Yeah, so the IDE support is not specific to one IDE. Instead, we use something called the language server protocol, which is a protocol developed by Microsoft to facilitate communication between a tool, so an IDE, and a language server, so a compiler. So the tool is going to ask the compiler to do things like it will tell the compiler, I opened this document, or the user changed this line in this document. And then the compiler can send back information like there is an error at this position in the document. And there are more commands, so the tool can ask for like go to definition, and then the compiler will tell you, well, the definition is in this file at this position. So the IDE support in Dotty is currently very experimental and not actually released. I have a GitHub branch for it, but no open pull request, but I should have one pretty soon. So I'm going to demo this using Visual Studio Code. So if you don't know Visual Studio Code, it's a new IDE by Microsoft. It's open source, MIT licensed, and runs using Electron. And it's basically the reference implementation for the language server protocol. But there are other implementations. If you go to langserver.org, you will find implementation for many tools like Emacs and Vim and VS Code, as well as many programming languages. All right. So I'm going to start VS Code. I'm going to hide stuff that I don't need. All right. So this is the collections Roman, which is a proposal for redeveloping the Scala collections for Scala 2.13 and Dotty. And it's a nice small project, which is a good way to demonstrate IDE support. So for example, if I put my cursor on some value somewhere, I will get the type. So let's say current has a type of, it's a sequence of A, and head as type A. And if I right-click and do go to definition, I will find the definition of head. So there are multiple definitions of head because it's defined in sec, but it's also overridden in lazy list and list. So using VS Code, I can jump to any of those. And let's go here. And I can do that as much as I want. So let's say I want to go to the definition of is empty. As you can see, it's pretty fast. Okay, so going to definition is nice, but how about finding all references? This also works. So we see all the definitions, and we also see all the cases where something is defined, is used, sorry. What else?
So Dotty, as you know, Dotty has a lot of new features, but we're also deprecating things that we don't use anymore. So one of those things that we are deprecating is the procedure syntax.
Yeah, so I think this feature is actually broken right now. But the IDE support also has support for telling you about errors and warnings. As you type things, you will get red underlines. And in some cases, you will get not an error, but a warning, and the compiler can do automatic rewritings for you. So here, it's not enabled, so I'm probably going to skip this, but basically, as I said in my presentation yesterday, this syntax defining a method using brackets without using equals is now deprecated. It's an error by default. It's a warning in the Scala2 compatibility mode. And the IDE can automatically rewrite your code so that it adds the missing part because it knows that this is what you should be writing. So this is not working right now, but I promise you it's going to be working. This is also very interesting because we can use that in a lot of other cases. For example, with ScalaMeta macros, we could automatically expand them to show you the content of a macro instead of the code you wrote, so that you can more easily debug your macros. This is something that IntelliJ, for example, already does, but in Dotty, we should also be able to do it. Oh, and we also have renaming working. So let's see, here's a from iterable method, and I can rename it to duck. Oh, okay. It broke, but in some cases it works. So it's still super experimental. Renaming is more complicated than other kind of transformations because when you rename something, you have to be very sure that you're renaming the correct thing. Otherwise, you're going to overwrite the user code with crazy stuff. So this might not be part of the initial release of the IDE. We'll see.
So why did we choose Visual Studio Code protocol?
Oh yeah, so we decided to go with this protocol, the language server protocol, even though it's not supported by a lot of IDE yet, because we think it's going to be the future, basically, or we hope so, that we only have to implement support for IDEs once, and then everybody can profit of it. Instead of having to spend a lot of time working on one specific IDE, like Eclipse, and in the end, people who don't use Eclipse will not benefit from that. Yes. Yes, so that's a very good point. So the language server protocol is evolving pretty fast. It's currently at version 3, but it doesn't have a lot of support for refactorings. There is one kind of refactoring it does, which is renaming, which we support. But it doesn't do more complicated things like moving code, out, like making a def out of some code or that kind of things. My expectation is that it's going to become easier to specify custom commands. And using custom commands, we can then do whatever we want. But we haven't explored that yet.
So one common question we get when we talk about this protocol is, are we stepping on Enzyme's toes using this?
Yeah, that's a good question. So it's kind of similar to Enzyme in that Enzyme also has a server and different clients which communicate with this server. But in the future, it's possible that Enzyme might use this protocol. And what Enzyme does that we probably will never do is much more complex interactions with like Java codes and external dependencies and fetching documentation and all that kind of stuff. So I expect that in the future, Enzyme will use this either with a protocol or as an API. So I only show you the user part here, but there is also an API to interact with the compiler that could be used by Enzyme. And the goal is to maximize code sharing, basically. But at the same time, we don't want inside Dotty itself to have to implement support for like analyzing Java bytecode, because that would be crazy, and there are people who work crazy who are already doing that. So we should let these people do that. But we still want first-class support for Dotty features in IDEs, which means that Dotty itself has to be the provider of all the information. More questions? Yeah.
It's tangential, but for the Scala compiler, the current Scala 2 compiler, if you put the flag for the fatal warning zone, then if you have depreciated, I mean, you die ungracefully, and there's no way to just shut the depreciated off. Like, I think there is some SBT plugin, like Silent or something like this, just to make it pass. How about in Dotty? Do you have this kind of granularity regarding like a deprecated or unchecked or things like that?
So far, I think we haven't even implemented fatal warnings. The flag does not exist in Dotty. So this is a very good first contribution. And it's true that when we implement that, we should make sure that you can turn off warnings. I think that, like, we showed you this thing with all the error messages that the user defined. And one interesting thing is that every error message has an error number, which means that we could have some feature to disable warnings, like a very specific warning. But so far, we haven't done that, and no one has stepped up to do that. But this is something that, like, if you are interested in, should definitely like open an issue or something so we can discuss it in more details. Better error messages, better handling of deprecation and feature warnings and all that stuff.
Thank you so much, because sometimes you are stuck. I mean,
yeah, I understand.
Yeah. Thanks.
Okay, so thank you very much for listening to this demo. And so tonight...
Right, so this afternoon I'm going to talk more in depth about Dotty and the sort of things that we do to promote outside contributors, because the part where you guys can actually help the most is when it comes to tooling and user experience. And I think that's one of the most crucial factors in getting Scala 3 to become this immensely popular modern language that we all want it to be. So see you then.